let's start off with the basics, the pinhole camera. You recall again, a pinhole camera basically had an opening, a small opening in a scene, and of course an image was formed upside down at the focal length at the image plane. An upside down image is formed there. In essence, we also kind of discussed this, that this point here basically captured all of the light in the scene at this point, and of course that's what was then projected at the back. Now, of course, you can imagine that any point on this surface here, the gray patch, which is basically where I have the pinhole, any point in the surface is also actually kind of capturing all the light. Of course, since it's no longer a pinhole, they're not actually coming in. So in essence, I could close this hole and put another hole anywhere else on this screen, and that will actually act like a pinhole. So you could actually put a number of points, pinholes, in this surface. And each one of them will basically then, for this point here, become the sensor, the light source that will actually create an image like this, of course, from a different viewpoint. So you can imagine now anywhere on this one surface here, the two-dimensional patch, I can put a pinhole and it would generate a different image, right? So in essence, that proposes to us that any point in this whole region has the same capability, not just on this two-dimensional surface. So a point here in space is also getting what we've referred to again when we looked at earlier stuff, is a bundle of rays of light converging to this point. And that bundle of rays of light here basically is captured here. And of course, if I was to put a pinhole camera, I would actually capture an image here. So this is a pencil or bundle of rays of light at this point. Of course, we need not actually just be stuck to all of the bundle of rays of light coming in from just one direction. Any point anywhere in the world basically gets all of the light converged to this point from all directions, right? So any point in this scene is basically capturing a whole lot of rays of light converging to one point. And it could be any point here, any point in the scene could actually be doing this. So just to kind of reiterate that point, a 3D scene, many points exist in that 3D scene. And I'm just pointing out, a few of them. So any 3D scene, there are lots of these points around it. Each one of them, a bundle of rays of light, are actually being collected at it in the 3D scene. Again, this is just pictorially showing it. Look around it, and any point in the scene, for example, here, all rays of light are hitting this point. Another point here, all rays of light are collecting at this point. I could actually create a camera, pinhole camera here that would capture all the light. And similarly, I could capture a ray of points of light here to capture all of the light that's hitting at this point too. Now, just to simplify this, we can actually say is that each point here can be represented as a sphere, right? All of the rays of light are converging onto the sphere from the world. So all rays of light are coming in to each and every one of these spheres from all three directions, right? So we can basically say that in essence, this world is full of these types of, specific spheres, and the point at that center is where all the light is accumulating. So in essence, any scene is full of these types of points. So in essence, again, that basically says any point in the whole 3D world is actually capturing pinhole types of camera information, except that we're not just capturing it. That point is already capturing that information. We just haven't put a sensor there to capture it.